Hi, we are Team 31. I'm Natalia.
Hi, I'm Himanshu.
Hi, I'm Drishti.
Hello, I'm Chaitanya, and now we'll be explaining you the complete process for the grammar we made named Cherish.
Hi, this is Himanshu again. I'll be giving an overview of the language. It consists of four primary components: grammar, parse tree, compiler, and runtime. Now, several tools and technologies were used for language construction. For instance, ANTLR is used to recognize and translate the grammar into an intermediate form. IntelliJ and Eclipse are programming IDEs in which ANTLR is used as a plugin to perform various operations. The compiler and interpreter are created using Java. All the code, including compiler files, interpreter files, grammar, and several others, are on a private GitHub repository. The language has a simple and easy to understand syntax. It consists of integer and Boolean data types, assignment statements, conditional expression, iteration expression, arithmetic and logical operators, and a display statement to print the output. So it starts with the provision of source code to the lexical analyzer, which then breaks it into a series of tokens. The stream of tokens is then forwarded to the parser, which creates the parse tree that encodes the syntactic and semantic information. Next is the compiler. Based on ANTLR's visitor pattern, which takes the parse tree generated by the parser and converts it into the intermediate code, which will be given to the runtime to generate desired output. The grammar consists of data types, assignment statements, arithmetic expressions, conditional expressions, if-else statement, comparators, iteration expression like while loop, and a display statement. There are two types of operators: logical operators, for example, greater than, less than equal to, greater than equal to, and similar types, and arithmetic operators, plus, minus, multiplication, division, and the modulus operator.
Now I'll explain the grammar. Every program begins with start and ends with end. Proc code is like a block of statements consisting of one or more statements. The statements can be assignment statement, conditional expression, iteration expression, or display statement. In assignment statement, we have integer assignment and Boolean assignment. Integer and Boolean are our data types. In Boolean expression, we have different logical operations and comparators. In arithmetic expression, we have addition, subtraction, multiplication, division, and modular function. Factors can be numeral or lowercase alphabet. We have if-else condition, where else is an optional part. Then we have while loop, which checks for a condition before executing a block of code. The display statement is used to display something as the output. Then we have greater than equal to, greater than, less than equal to, equals, and not equal to as the comparator. Boolean values are true or false, and instances are a combination of numbers like from 1 to 9, which is not beginning from 0, and we also have 0, and we have lowercase alphabets. In intermediate code generation, we input the high-level program and generate the parse tree. The compiler visits each node in the parse tree and generates intermediate code. The keywords that we have used are add for addition, sub for subtraction, mul for multiplication, div for division, and mod for the modular function. We have LT for less than, GT for greater than, LEQL for less than equal to, GEQL for greater than equal to, and EQL for equals. Display is capital display. For while we have used iterator in capital, and for if we have used if in capital. Now Drishti will explain some of the sample programs.
Hi, I'm Drishti, and I'll be explaining you our intermediate code. We have created a class CherishIC which extends all the methods of the class baseListener. Here we are creating string builder and the complete IC will be appended in this. Like the exit integer assign method appends MOV in the IC whenever there's an integer assignment statement like int a equals to 5. Similarly, we have written methods for operators like add for plus, sub for minus, if for conditional expressions, iterator for while loop. Also, whenever there's any Boolean expression, for instance equals equals, less than equals, etc. are encountered, it will append EQL, LEQL in the IC. Now I'll show you some sample source code along with the intermediate code generations. So here's our first sample code. In this first statement, int a equals to 2, this statement is translated into 2 lines of code per IC, that is push to and mov a. Firstly, 2 is pushed onto the stack and moved into a. Similar is the case for variable b. Now display statement is kind of print statement which prints the value of any arithmetic expression inside the braces. Get a in the IC will take the value of that variable. The plus operator in a plus b will append add and the result will be moved to c and it will then be displayed by the display statement. So here's our parse tree for our first sample code. Then we have second code in which we have also included if statements and while statements. So whenever if is encountered in the source code, if is appended in the intermediate code. An exit bool saves the result of the Boolean expression inside if and as well as for while statements. So here if we see if a greater than b, then if the result is true, it will display a, else it will display the value of b. Similar is the case for while. If b is greater than equals to 2, it will enter into the braces. It will update the value, increment the value of a to a plus 1 and display addition of a and b. Then it will give the value for b is equals to b minus 1. And this closed curly bracket corresponds to the iterate end in the intermediate code. Similarly, we can explain the intermediate code for source code of this program as well. Here we are doing multiplication of a and 10 and giving result into a. Same is the case with fourth sample code and with the fifth one. Now my friend will be continuing with the next slide.
Hello everyone, I'm Chaitanya Ahuja and I'm gonna explain you about the runtime. So this slide is showing the complete workflow from input, or we can say the source code, to the console. First, it is converted into the IC using CherishIC.java. Then its output is fed into cherish.java to handle the runtime and displaying the results on console. Now I'll be explaining you guys how we are implementing all this using the code. So here this is the file for cherish.java. Here we are creating a hash map named symbol table with 2 arguments, the first as string and the second as integer. For example, if you want to store a number in a variable a, the string becomes a and the integer becomes that value. We are using a stack, namely int stack, to handle the arithmetic expressions. The Boolean stack will be storing the Boolean values from the comparators. The is iterate is used while handling while loop, which is called as iterator also in our programs. Now these functions move to begin and move to end will handle the flow of execution during conditional and iteration expressions. So now there is a switch statement which recognizes keywords from the intermediate code and acts accordingly. For example, here in display, if it encounters a display keyword, it will simply pop the other element which will be in the stack and display that on the console. The add operation is done using the stack and adding and popping two elements and adding them and storing the result. Now, one thing which is to note here is in operations like subtract, multiply, divide or mod, that we have to make the arguments upside down using the temp variable, so it can give the right results. As it is a stack, so it is kind of last in first out. uh, now these statements like equal LTKs are handling the comparators and filling the boolean stack with their values. If they are giving a positive, then if they are giving a 1 or a 0. Likewise, the greater than, equal to, not equal to. Now here the exit boolean stores the boolean value after the comparator operation inside if statement or while statement. This will handle the else keyword whenever it is encountered in IC. Now let's check one of the example how it is being mapped. So here we are given with the intermediate code. The first is push to and move A. So in this case, it will occur with the push case will happen, where the push will be the first argument and the second argument, that is command 1, will be 2. So 2 will get stored in the stack. After that, move A, the first argument is move obviously, and the second will be A. So the command 1 is A, and then the instack dot pop, that means it is transferring that 2 into this variable A. So we can also say that it is A is equal to 2. Likewise, the print statement is there, display. Now we are here given with other statements of mainly display and multiply. We have one multiply here, I showed you on the code, and likewise if is also handled. Thank you so much guys for listening.